Between January 2024 and April 2026, professional scientific and military instruments logged a dense, highly localized surge in anomalous aerospace events. The data tracks two distinct phenomena: a 3.9 sigma spike in meteor-class fireballs recorded by the American Meteor Society, and a sustained pattern of metallic, spherical UAPs documented by the Department of Defense. Data from official hazard reports defines a specific profile: 1 to 4 meter spheres with no wings, control surfaces, or visible exhaust. Navy pilots recorded these craft moving at Mach 2 without acoustic shockwaves, and sensors confirmed instantaneous direction changes, stopping from supersonic to a hover. A physical object cannot displace atmospheric air at Mach 2 without generating a pressure wave, nor can it maneuver without reactive thrust. These documented flight characteristics violate the established principles of aerodynamic drag and propulsion. From an engineering perspective, a sphere is the least efficient shape for supersonic flight. Pushing a blunt object through the atmosphere at high speed forces the air to compress violently, creating massive turbulence and a deafening bow shock. Building a craft that ignores shockwaves requires expertise found in only a few elite laboratories. But the specialists capable of conducting that research have recently begun to disappear. In April 2026, independent researcher Jose A. Perez published a theoretical analysis targeting this specific kinematic profile. It treats the sensor data as veridical and seeks the minimal physical framework and material blueprint required to construct a vehicle capable of these maneuvers. Perez models the vehicle as a system interacting directly with an underlying quantum coherence field, bypassing the constraints of traditional fluid dynamics to resolve the observed paradoxes. Sustaining resonance with this field relies on maximizing the global phase alignment across the entire volume of the system. Success depends on the stability of this specific phase term. Standard aerospace geometries, like swept wings or nose cones, create inherent directional bias. This asymmetry produces high phase variance at the system's boundary, disrupting the resonance required for field coupling. A sphere is the unique closed three-dimensional geometry that minimizes boundary phase variance because every point on its surface is equidistant from the center. This geometry also provides an immediate kinematic advantage. Without a nose cone or tail, the vehicle possesses no preferred forward axis, enabling the omnidirectional maneuverability reported in military sensor logs. The prevalence of the sphere in current observation records aligns with these rigid mathematical requirements for coupling a physical mass to the coherence field. This framework also accounts for the lack of visible thrusters or chemical exhaust during high-speed flight. This equation defines phase-locked locomotion. It describes a system that modulates its local phase gradient to generate movement. Rather than ejecting propellant mass to create thrust, the vehicle exchanges momentum directly with the ambient coherence field. It pushes against the vacuum of spacetime. This eliminates the need for combustion, which explains why infrared sensors detect virtually zero waste heat or exhaust plumes. By leveraging highly organized internal energy to grip the field itself, the vehicle operates independently of the surrounding atmosphere. Conventional physics dictates that a solid sphere moving at Mach 2 must generate a massive detached bow shock and a loud sonic boom. The coherence field equation addresses this through the effective interaction cross-section. High resonance amplitude alters how the vehicle interacts with its environment. Using a mechanism parallel to the chameleon scalar field in cosmology, elevating the local coherence amplitude exponentially suppresses the object's aerodynamic footprint. The surrounding air ceases to react to the geometric bulk of the sphere. This same math applies to inertial mass. An instantaneous turn that should generate 1,000,000 Gs of force is suppressed at the source, meaning the effective load remains within survivable limits for the vehicle's structure. By mathematically cloaking its mass and volume from the physical environment, the system operates with the acoustic discretion and extreme acceleration recorded by sensor networks. Sustaining this continuous coherent state requires a specific internal architecture. The framework requires a multimodal high-Q resonator, a physical structure capable of sustaining phase-locked oscillations at several frequencies simultaneously. The optimal geometry for this resonance is a series of nested shells made of differing densities. These layers act as a coherent cavity to maintain the highest frequency modes. In March 2025, X-ray analysis of the recovered Boogosphere artifact reported an internal structure of exactly 3 concentric, seamless layers of differing densities. Regardless of the artifact's provenance, its reported physical construction aligns with the specific structural geometry dictated by the theoretical model. For a coherence-coupled vehicle to survive flight in Earth's atmosphere, its outer shell must meet extreme material science constraints. The substrate must maintain its structural integrity while surviving high-energy, oxygen-rich environments without burning or cracking. Mondalloy, a nickel-based superalloy invented in the mid-1990s, was designed to solve this exact engineering problem. Aerojet Rocketdyne utilizes Mondalloy as the enabling material for the AR-1 engine, which powers the heavy lift vehicles required for national security missions. The outer envelope of an anomalous craft requires the properties found in highly advanced oxygen-compatible superalloys like Mondalloy to contain the internal resonance. While the chemical composition of Mondalloy is known, the complex process knowledge required to forge and laser melt it into seamless shapes was held by only 3 people. The personnel cluster currently under federal investigation includes the stewards of that specific material. Dallas Hardwick died in 2014, Monica Jacinto Reza vanished in 2025, and retired Major General Neil McCasland disappeared in 2026. They are part of a wider cluster of 11 deaths and disappearances involving nuclear and plasma scientists from institutions like Los Alamos and NASA JPL. When the only people capable of manufacturing these materials are systematically removed, the pattern suggests a targeted industrial counterintelligence operation. The governing equations for frictionless flight are mapped. The materials are real. The Coherence Field equation provides a mathematically disciplined blueprint for anomalous behavior, moving the subject from the realm of speculation into the domain of applied engineering.